Alright, so a very good morning to all of you. So my name is Robin. I'm a year 3 student in NUS Computer Science. So I specialize in software engineering. Just to let you know, these slides I created it 8 hours ago. I lost my deck of slides. So there are some information which are not accurate. So I will post the latest one on the slide. Okay. So don't worry too much. Okay, this workshop, okay, I try to make it as simple as possible because this is actually a module, level 4000 module in NUS. Okay, but don't worry. Okay, I'll try to make it as simple as possible. Right. The objective of this workshop is to learn the different methods of testing. Okay? Hopefully, you can appreciate why testing is so important and why you should allocate time for it. Okay, so let me move on to the next slide. Hopefully this is working. Okay, so these are the 4 main points of mention. Okay, I'll try to elaborate as much as possible. So number 1, why is software testing effective? Okay, this one I'll explain why. How do you test a software? Okay, so testing a software is not as easy as just do random testing. Okay? Random testing is good, okay, for some of its reasons. For example, you don't have any biases. Okay? Sometimes when you code too much and then you want to test a code, you realize that sometimes random testing you can find some other bugs or some other errors, okay, that you didn't manage to find, okay, at the start of the code. Okay? So I'll talk a little bit about random testing later. Okay, and I'll tell you that actually you need to do both random testing and systematic testing. Okay, so the main aim of this workshop is on systematic testing. What are some of the methods to apply in your design? Okay, so the third point is on how can you generate more test cases. Okay, so this for this point there are a few approaches you can go into. Okay, whether is it functional testing or structural testing. So this one I'll talk about later. And lastly, I'll just show you some demonstration on how you can use automated tools to run your test cases automatically. Okay, so like for example, this time I'm showing using Travis. Okay, and hopefully you can use it in your projects, in the subsequent projects. Hopefully I covered that. Yes. Okay. So any questions at this point in time? No? Okay. Let's move on. So the main reason why we do software testing is because we want to ensure that the quality is there. Okay, that's the main reason. If you do not understand the information later for the rest of the 2 hours, okay, this is the main thing. Okay? Software testing, the main aim is to ensure that the quality of the project is there. Okay? So in terms of quality, quality assurance, okay, quality assurance is the process where we ensure that the design software has that quality. Okay, so in terms of quality assurance, we have these 2 components. One is called validation, the other is called verification. Okay, validation means that you build the right system, which means you ask yourself whether your requirements are correct. When I mention requirements, it's more about user stories. Okay, it's a similar idea, right? So you need to ask yourself whether are you coming up with the right user stories? Are you coming up with the right requirements for your project? And sometimes you might have the problem, but the requirements that you come up with doesn't really solve the problem. Okay? So that's the very first thing that you should do. You need to find out whether your requirements are defined correctly. Okay. Secondly, are the requirements implemented correctly? So sometimes when you write everything on paper, like all your requirements, you write everything in black and white. And when you type out in terms of code, it may be a different story. Okay, sometimes it depends. Okay, when you implement a code, you might implement it in a different way, and you might not notice it. Okay? You thought it's the same, but when you implement the if else, while loop, and everything, it's actually a different story. Okay, so it's very important that you need to see both sides of the story. Okay? One is the black and white, your requirements are black and white. The other one is on your code. Okay, so at this point in time, I hope you understand, okay, the quality assurance part. So if you want to look at quality assurance from different perspectives, So I just share with you as a student. Okay, this is something that we always aim for. You know, to get your A in projects. Okay, you want to ensure that you want to get your confidence, right? So how you measure confidence? Usually we look at the coverage, right? In terms of code, how much coverage have you covered in your code in terms of your test cases, right? Secondly, is on fault based. So for example, whether you checked every single part of the code that shows that there's no fault at all, and failure based. So for this workshop, I'll focus more on coverage based. Okay, because the other two requires a lot of formal methods, okay, which are not covered because that one is a bit too extreme for this workshop. Okay, so as a student, okay, you can see that confidence, measurable confidence is quite important, right? So as you progress into a software engineer, okay, you'll know that actually you need to understand the requirements properly. All right. So what's the role of a software engineer? You need to ensure that your code is correct. Actually, these two words I quoted from my previous manager presentation. Okay. When I asked my manager, because I was doing testing for their company, okay, I'm supposed to do testing in terms of their of a particular feature, okay, in their application. So when I asked my manager, what is the purpose of testing? And this is what he told me, okay, correctness and completeness. So it's actually similar to what I mentioned just now about validation and verification. It's the same idea. Okay? So hopefully this is another way that explain in terms of quality assurance. Okay. Lastly, for business user, okay, when you come out with a software, when you come out with a prototype, you don't just do for the sake of doing it. You don't just do for the sake of getting a things, right? So you need to look at your target audience. Okay, usually target audience will be your business user. So suppose you want to design a software for elderly, right? So have you taken care of their user experience? Okay, user experience could be in terms of the UI, whether is it user friendly for them. It can be in terms of performance as well. So performance, like for example, whether is it fast or slow, whether is it so like user friendly for the user. Okay, so actually for business user, right now in my current internship, I'm doing testing for business end users. Okay, so that's why I'm the most suitable person to talk about software testing because I went through all three phases. Okay, previous internship I was back end software engineer. Okay, and yeah, all the while the student at AWS. Okay, so hopefully you can see why software testing is so important. Okay, and at this point in time, are there any questions? Anything you want to clarify? Just feel free to ask. Feel free to stop.
What do you mean by coverage based? Just because what do you mean?
Okay. Later I'll cover some of the criteria, coverage criteria that you can take note. Okay. Actually, in terms of coverage, you can see that in terms of your code, you can increase the coverage. That means you can check all the different corner cases, okay, and ensure that you maximize all the coverage possible. I'll cover that in the structural testing part. Okay. So, any other questions at this point in time? Okay. No. Okay. Let's move on. So this is the very first code you will see for today. Okay. Before I mention this code, I would like to clarify these three terminologies. Okay. In terms of testing, a lot of people might get confused whether do you say your code has fault, your code has an error, or your code fails. Okay? These three words has its own differences. Okay, so let us look at this particular code. Okay, the aim here is to replace all the elements in the array by the character X. Okay, so this is the code. All right, it's very obvious where the problem is. Right, the problem is here. Right, so suppose you don't know. Suppose you don't know. All right, okay, you don't know that this is actually the issue here. Okay, you should use something like array.length or something like that, right? Suppose you just look at this, okay, and you try a sample input. Here is a sample input. So suppose you have an array, 4 elements, okay. The the first one is R, L, and Z. Okay, so what will be the output? The output is actually X, 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 right? Why? Because you go through the for loop 3 times, okay, and you will just continue all the way until the last element. Is that right? No, right? So actually you'll stop here, right? So actually you'll stop here. So you go through 3 times, 0, 1, 2, and then you stop here. All right. So so the program will exit normally. Okay. Actually, it should be 3, right? Is it 3?
Yeah.
0, 1, 2, 3. I think it should be 3. 0, 1. Yeah, it should be 3. Okay, it's a typo error. So, okay, here we see that there's a fault. Okay, if you look at your notes, I've put in the definition of a fault. Okay, but this is just an example to show you that. Okay, here there's a fault because this number should be replaced by a rate of 1. Okay, but it's not an error. Why? Because the actual output is actually correct. You notice, okay, even though the number is wrong, okay, the output is actually correct. I want all the elements to be updated XXX, right? So actually there's no error in the output. So there's no error in this program. Okay, there's also no failure because there's no runtime error, there's no compilation error. Okay, it runs there's no array out of bound technology that causes it to fail. Okay, so this is a simple example, okay, of how a fault can happen. Okay, suppose now you see something like this. Okay, now we have extra element here. Assume that is I less than 3. Okay, and you see that the program exits normally. Okay, the last element is not updated. Okay, because it just stops over here, it doesn't update the next element over here. All right, so what happens here? Okay, the fault is still there, right? The problem is still here. Okay, error is there. Why? Because the output is wrong. I want everything to be all X, right? Okay, I want to replace all the elements by X. But here, it's not updated. Okay, because I only stopped up to here. Okay, so the error in the code is present. Okay, but does it fail? It doesn't fail, right? Because it successfully runs all the way, and there's no compilation error, there's no runtime error. So this is the difference, right? Just by using different inputs, okay, you can get different types of problems. Okay, so I gave a hint just now. So this is something like array out of bounds, right? So you want to set it, okay, let's say here is 1i less than 2. Okay, here we only have 2 elements. Okay, so you will go array out of bound, right? So when it goes array out of bound, although the output is correct, okay, the program will behave incorrectly because there will be array out of bound error. All right. So the fault is there because the number is wrong. I want to replace all the elements, right? So it should be array out of bound. Error is still there because I didn't manage output. So if there's an array out of bound, the output is not being produced, right? So there's error. Failure, yes, because array out of bound. Okay, so I hope I clarify on these 3 terminologies: a fault, an error, and a failure. At this point in time, any questions to ask? Am I going too fast? All right. Okay. So, okay, I'll just cover some terminologies that we use in testing. Okay, so this is just a general idea, okay, about some of the testing terminologies. Okay, so when we talk about test case, okay, we talk about a group of input values that cause a program to take some defined action. Okay, so that means suppose you want to test a particular method in your program. Okay, so you write a test case, okay, to make sure that the method runs as expected. Okay, the output is actually correct according to your input. So this is what we mean by a test case. But when there's a collection of test cases, we call it a test suite. Okay? It's called a test suite. Okay, test oracle is a mechanism, okay, where we determine if the actual behavior of the test case matches expected behavior. So whenever when we run a test case, there are two things that we need to take note. One is the expected output, and one is the actual output. What's the difference between the two? Okay, expected output is the output that you want it to happen. Actual output means after the code has run, that is the output that's provided by the program. Okay, so these two expected output and actual output, these two has its own differences. Okay, so test effectiveness. Okay, later on we will talk about some of the coverage criteria, for example. So you can look at the degree in which your testing reduces faults or achieves other objectives. Okay, so for example, whereas you want to have 100% coverage, right? This you can use some of the coverage criteria later to see the test effectiveness. Okay, and lastly, I think for testing, it's very important to come up with a test plan. Okay, a lot of us would leave testing all the way to the last. So after we implement our code, then we do the testing component, where we write test cases to test our program. Okay, here is what I suggest. Okay, whenever you write a certain method, you write a test case for it. Okay, later on I'll cover this part. This is called a test-driven development. Okay, how is it useful? Okay, so when you write a small method, okay, in your program, okay, after that you write a test case to cover this method, you can be sure that this particular method works. Okay, and when that particular method works, and then when you venture into other methods or write other code in your program, okay, it does not. You minimize the problem of debugging. Okay, you'll reduce the chances of needing to spend time to debug your program for hours. Okay, so a test plan, when you write your code, try your very best to write test cases as early as possible. Okay? Just to make sure that your particular method or your particular line of code works. Okay, so this is very, very, very important. You should start it as early as possible. So that's why when we talk about test plan, okay, you should start as early as possible. Okay, don't leave it all the way to the last. Right? At this point in time, any questions? Anything to clarify? Okay, if not, okay, I'll just cover the differences between testing and debugging. Okay, so testing would review all the faults in the code. Just now we have seen some examples of faults, right? So testing will review all the different faults in the code. But when we do debugging, we are actually trying to find the particular bug and try to remove it. Okay, so debugging is actually part of testing, right? So whenever you try to rectify the bug or rectify the fault, you need to test it as well to make sure that whatever you have changed will work. So that's why I mentioned that debugging is part of testing, and this is the differences between testing and debugging. Any questions at this point? No? Okay. So now I come to this part where I mentioned about random testing and systematic testing. Okay. So random testing, okay, is about you choose your inputs randomly, right? So that means you just take a program, okay, as it is, and then you try any input that you like to try. Okay. So of course, random testing has 2 points, like what I mentioned just now. It minimizes the programmer's bias. So, like for example, when you specify your user stories, when you specify your requirements, okay, sometimes you might not see some corner cases, like what I mentioned, right? So, sometimes when you do random testing, you might unintentionally find things that you never implemented before. Okay, this is quite common actually. So, whenever we do random testing, okay, it's always assumed that we treat all the inputs as equally valuable. I hope this makes sense. Okay? So here's about random testing. I'll talk about systematic testing. So systematic testing, okay, we have a systematic method, okay. I should say systematic steps to take okay, to generate all the test cases and make sure that all these test cases work. So unlike random testing, where we just try according to what we think, right? So in terms of systematic testing, we come up with a plan, we come up with a strategy, we come up with test cases, and run all these test cases. Okay, so maybe I'll just ask one question. So should we do random testing or systematic testing? What is your answer? What's your answer? That's fine. Okay, you must do both. Okay, don't just focus on systematic testing just because you think that random testing it's just random. Okay, actually it's not. Okay, sometimes you need to do both at the same time. Okay, sometimes you might not see some of the things that you never implement. So it's better that you do both at the same time. Okay, but put more emphasis on systematic testing. Okay, just put more emphasis on systematic testing. So if you ask me, what should be the weightage? Probably 70% on systematic testing and 30% on random testing. Okay, so let's move on. Wow, what is this? Okay, so I just mentioned that I made these slides 8 hours ago, from scratch. So I don't know what's happening in the animations part. Okay, so now I'm going to cover the types of testing. Okay, so testing is a very big component on its own. Okay, at the very beginning, okay, we need to do unit testing. Okay, what is unit testing? Unit testing means I use a test case to test a particular component, okay, in an isolated environment. So later on, when you open the repository that I sent in Slack, right? I hope you have opened it. Okay, you can see some of the unit test cases. Okay, later on I will show you again. Okay, when we go through the debugging process. All right. So unit testing you can do in terms of a procedure. Okay, procedure here means that it's a method also. Okay, so you can test a particular method or you can test a particular class on its own. So it really depends on how you implement your code. All right. Sometimes your class can be very simple and you can just test it on its own, a class on its own. Okay. Or sometimes you have many different methods. Okay. It's more advisable that you test each and every method. Okay, using unit testing. Okay. So after you have implemented all your unit test cases, okay, it's very common that in software engineering, you work with different people, right? So different people might be writing different unit test cases, right? Different people might be implementing different parts. Right? For example, your authentication, for example, your different features, right? For example, your front end and back end, your UI and whatsoever. So you need to do this testing called integration testing. Okay. So integration testing simply means that you test the different parts of the system by combining the modules. Okay. So one example like what I mentioned, sometimes when you distribute your different roles and responsibilities in the project, okay, some of you might be doing front end, some of you might be doing back end, some of you might be doing different features. Okay. All these might have issues. What kind of issues are there? So, for example, sometimes there's misunderstanding of the requirements. Okay, when you want to implement something like, I just want to implement an authentication system, okay, using let's say Google, okay, but your other members think that maybe you are using some other platform, not just Google. Okay, so when there's such mismatch of understanding, okay, on the requirements, okay, integration testing will help to alert you on this issue, okay, and try to resolve it as early as possible. So that's why you should do integration testing. Hopefully, once every week. Okay, if you are doing a orbital project right now, you should do at least once a week. Okay, so that you can make sure that all the things that your group members are working on are working well, right? When they are combined together. Okay, so it's very important. It's not just for your orbital project, for your future software engineering modules as well. Okay, especially when you're working in let's say CS3201 project or let's say 103 project, you're working with about 4 to 6 people, right? And it's very important that you know each and everyone's code and make sure that they integrate properly. So integration testing is very important. So after you have done all the integration and you say that, oh, everything is fine, working fine, everything can be merged properly, everything is working well, you need to do system testing. Okay, so what is system testing? So sometimes when you implement your code, okay, other members manage to work well with your code. Okay, sometimes there might be issues with the requirements. Okay, requirements means those user stories or all those features that you have planned earlier. Sometimes it might break. Okay, when you merge certain modules or certain classes, right, it might cause issues. Okay, with your current implementation. And sometimes you might not know. Sometimes it might be caused by your other group, which is very common. Okay, so it's very important that you do system testing. Okay, you do a thorough check. Okay, from the starting of the input, you try to run each and every one of the code. Okay, and you check the output and see whether it matches with the requirements. Okay, so that's why system testing. Okay, you'll see that system testing is important at the very last stage. Okay, after you have done all the integration properly. Okay, so after system testing, okay, this acceptance testing is more on the end user side. So for example, when you implement your app, let's say mobile application for your I don't know, I like to say elderly. So if you implement it for the elderly, you should let the elderly try as well. Okay, because sometimes when you implement things, okay, you might not think from the elderly's point of view. Okay, so it's very important that you do acceptance testing, okay, for the end users to try out, okay, and see whether there are any issues with the current implementation. Okay, acceptance testing is also in terms of business point of view, where we, let's say you are coming out with software for a particular business. Okay, so the business end users, okay, they need to test the software as well, but they won't see the code. Okay, so that's the difference between acceptance testing and the rest of the testing. Usually, acceptance testing, you won't see the code at all. You just take the prototype on its own, and then you just test it. Okay, you test based on your based on the requirements, based on your use cases. Okay, and you check whether the output matches your expected output. Okay, so acceptance testing is quite common when you go into business industries. Okay? So acceptance testing, there's alpha testing, beta testing, I won't mention, okay? But the idea about acceptance testing is for the end users to test your prototype. Okay, so I'll just put it this way. Okay, lastly, regression testing. So regression testing means that suppose you have tested everything. Okay, your end users tried it, okay, your developers all tried it, okay, everything works fine. Okay, but when you want to build your project further, or when you want to let's say you want to implement more features, or you want to do some upgrades on your particular system, you need to do regression testing. Okay, regression testing means that okay, you test based on your previous test cases. Okay, so for example, let's say you upgraded the Java version, okay, in your project. Okay, some things might break, okay, because some of the components might not be supported by the new version of Java. Okay, so it's very important that you need to run regression testing to make sure that all those test cases that you have created before actually passes. Okay, before you move on to work on your code. Okay, so although I put this as a very last step, okay, actually regression testing, it should be done at any stage. So between unit testing or integration testing or system testing, you should do regression testing also. So just a clarification based on regression testing. Okay, regression testing is based on your past test cases. All these are actually new test cases that you create. Okay, so that's the difference between regression testing and the rest of the testing. Okay, at this point in time, any questions to ask? Anything to clarify? Is it clear? Or am I too fast? Okay. Okay, so wow, okay, next section again. Okay. So after you know all the different types of testing, okay, I'll just show you the different approaches in testing. So actually there are two main approaches in testing. Okay, so one is black box and one is white box testing. Okay, the differences are actually very distinct. Okay, once you see the diagram later, you understand straight away. So like what I mentioned just now, black box testing and white box testing. Okay, black box testing. If you go into software, any software engineering internship, or if you go into any software engineering industry, we call it functional testing. Okay, functional testing, like what it says, okay, it means that you test the functionality of the prototype, right? So you ignore the internal mechanism. That means you just treat the code as you can't see the code at all. Okay, you just use your input and check the expected output. Okay, check the actual output whether it matches the expected output. In really what sense? So this is the diagram that I want to show. Okay, this is actually your, let's say your project or your prototype or your software. Okay, whenever you talk about black box testing or functional testing, okay, you just use your input, you put into the software, and you get output, and you check the output. Okay, check whether it matches the output that you are thinking of, that you have that you are expecting. Okay, so like for example, let's say you want to test WhatsApp application. You want to test whether there are any bugs in WhatsApp application. Okay, so you try navigating to different features, maybe search filters and everything. This is called black box testing. Okay, why? Because you can't really see the implementation of the code in WhatsApp, right? So if you are doing such testing, okay, so this is called functional testing. Okay, so functional testing, you won't see the code implementation. So like what I mentioned here, internal mechanism is unknown. You don't know what is inside the software. You just test based on input and output. Okay, so white box testing is the other way around. All right, you know what is the code. Okay, basically you know what is happening inside the code. You can see the code implementation, and you test the code inside it, right? By passing in the input and you check output. So the difference between black box and white box is that white box you can see the code. Okay, you can see all the different classes, methods, procedures, or whatever. Okay, you can see the whole code implementation. Okay, and you test individual methods. Okay, so so like white box testing, you test the internal mechanism, okay, with respect to some well-defined coverage criteria. So coverage criteria I'll mention later, right? During structural testing, right? So usually for white box testing, we use coverage criteria to ensure that we cover most of the cases or most of the branching. Okay, let's say if you do if else, let's say if you use while loops and everything, we want to make sure that everything is covered, right? So white box testing, we try to make sure that we cover most of the cases. Okay, later I'll mention that it's not 100%. Okay, I'll mention the reasons why later. So at this point in time, any questions? Are you absorbing? Cool. Okay. Okay. So right now at this stage, I just mentioned all the terminologies. I talk about the approaches. I talk about the types of testing. Right. So right now I'll zoom into the more theoretical part of testing. Okay. So in terms of testing, you can test based on the model. Model meaning based on your code implementation, or you can test based on the specification. So specification means that maybe, for example, your use cases, your user stories. Okay, so there are two ways that you can do testing, right? So let me see. So yes, so these are the two main types of testing that we do, okay, in typical software engineering project. Okay, so I'll cover model-based testing for now. It's actually very straightforward. But before I start on model-based testing, I'll cover this thing called finite state machines. Okay, if you have taken CS400, very familiar, you should be very familiar. Okay, but don't worry, okay, finite state machines actually, to be honest, when I went for internship, they seldom use it. They just tell me the only what to do. Okay, but it's very good to do testing. Okay, because you can look at one glance what you're supposed to test. Okay, so for the benefit of people who haven't taken 210 before, so finite state machines is basically a type of model, okay, that you describe a behavior. Okay, the keyword is on sequence of events. So whenever we deal with sequence of events, okay, we will use a finite state machine typically to model such to model all the sequences of events involved. Okay, so so in a finite state machine, okay, there are these three components. One is the state. Okay, the state of an object, okay, is actually modified by methods. So over here, you can see that the light off or light on is actually a state on its own. Okay, so when you want to change from one state to another, you need to have a transition. So the transition will actually model the methods. So for example, if you want to change the state from light off to light on, okay, you need to have an action. Like for example, someone enters the room. So assuming that this is like a light sensor, okay, initially the light is off. When you enter the room, the light is on. Okay, when you leave the room, the light is off. Okay, so you can model a simple example, like a light sensor, using this diagram over here. Okay, so here comes the first exercise, very easy one. Okay, take out your pen and paper and draw a finite state machine for a traffic light. Yes. So a typical traffic light can see, okay, try to model it using a finite state machine. It's quite similar, okay, but I must think of the transitions that I must draw. Is it too easy? I don't know. Most of you are smart. Then I can go with more detail. In fact, I brought my notes here, just in case some of you might be interested to know more detailed examples. Okay, I'm prepared. So just let me know, okay, if you want more detailed examples. Right? So as of now, okay, let us try to draw a machine for traffic light. Okay, this is very important. Okay, later on when we talk about the coverage criteria, you'll see that actually this diagram is quite important. Okay, so this one I'll start off with finite state machines. Any questions? Let me know. Right? Please let me know. Maybe I think all of you about 1 minute to do. Okay, I don't think it's very difficult. Even the diagram just now. You just need to implement another 50% of it. Yes. Did you get my hints? I know how to implement it. Okay, so maybe for the states, just to make it very simple, just red, yellow, and green. Right? So we usually see these three lights in the tree. If we don't talk about the arrows and everything, we just talk about the three lights that we typically see in the traffic light. So a key dimension is the state. So I mentioned the three states that you need to have in the diagram. Right? And how do you come up with the transition from one state to another? Like this.
Go.
Yeah. really that we really just find out something. How can you specify that transition? You know, in some cases, programming you need to type. Wow, very good. Wow. Hey, what is that? I thought it's very good. The way to read.
Oh, I didn't come for the first class, so I have no idea what you're saying. It's fine, it's fine. I can catch up after this.
But this one is very important. Later on, you will build up from this concept. That's why I put this exercise here. Okay. So sometimes you want to follow your whole project. This is one way you can do. So you look at so I suppose that just like transition is very important. What is it? To change one step. That's it. So, suppose now the example is So how will you
Three lights. The trigger is time.
after you've drawn it? Okay, I'll mention that this is very important because when you see data parts, especially coverage criteria, you see that this is actually very important. When you see the different paths and everything, right? So this is the usefulness of it. I think the pattern is the same. Okay, so shall we go through the answer? Okay, I've seen that 90% of us have this answer. Okay, 90%, right? So why I mentioned that the numbers are important because you need to treat it as a program by itself. When you program this backend part, okay, using code, you need to mention the time. It is very important. Right? I saw one person. Okay, actually this is actually the model answer. You need to draw this actually. Okay, let me just draw here. You need to draw. Hopefully I can draw. Apparently I couldn't. Okay, so now I can show my laser pointer. All right, so you need to draw a self loop over here. Okay, the red you need to draw a self loop over here. The green you need to draw a no, actually red you need to draw a self loop. Okay, because for example, let's say there are no vehicles, right? You just stay red forever. It won't be like 30 seconds and it will change between. Okay, for example, some of the traffic lights look this way. Okay, so you can draw a self loop, that will be even better. Right? So this is one way that you can improve on this. Okay, according to the requirements. Right? So if the requirement says that it doesn't need to turn green. Okay, it doesn't need to turn green after 30 seconds. It's only when the car comes then you change the traffic light to green. Then you have to implement the self loop. Okay. So yeah, just want to mention that self loop is possible. Okay, for finance. Okay, any questions? Any questions? If not, I'll continue. Okay, so whenever we talk about this model, okay, we look at two different types of coverage. Okay, this is very important. At this point in time, this is very important. Number one is the state coverage. This state coverage is not the press coverage that you see on the internet. Okay, this state coverage means that every state in the model is covered at least one test case. So just now you have seen, let's say for example, traffic light, you see 3 different states. You need to make sure that each state is covered. Okay, so next one we look at is on transition coverage. Okay, transition coverage. Okay, we need to see that every transition between states in the model is covered by at least one test case. So what do we mean by transition? So the arrow that you draw, okay, you need to make sure that arrow is covered by at least one test case. Okay, so usually we look at transition because whenever you have a transition, you cover at least 2 states. Make sense? Okay, whenever you have one transition, you have 2 states covered. All right. So instead of looking at state coverage, we look at transition coverage. Okay? Usually, transition coverage is the most commonly used criteria. Okay. This is a type of example, okay, that you can do for model coverage. Okay. In the notes, I hope I put it in. Let me see. I hope I put it in. Okay, so in the notes I put it here under decision structure models. Okay, so for model diagrams, okay, that you have drawn just now, it can be modeled into a decision tree. Okay, for example, let's say, for example, a chatbot. Some of you might be implementing a chatbot. So you are wondering how a chatbot actually works. Okay, it works according to decisions made by the user. So suppose the chatbot asks a question, you answer a response, and it checks the response. If it answers this kind of response, then this is the next question to ask. Right? And then you answer a different one, then you keep continuing until it becomes a tree. Okay? You can actually come up with this using finite state machine as well. Okay? But here I'm going to talk about this method that you can use, okay, to model such a decision tree model method. Okay, so this is called the modified condition decision coverage. Okay, in short we call it MCDC. Okay, so I'm going to go through how you can apply this, okay, for decision tree models. Okay, so here is the problem, very simple problem. Take a look at this problem. So an aeroplane has 4 engines, okay, 2 engines on each side. Okay, suppose this aeroplane can take off with a minimum of 1 engine on both sides. So yeah, maybe I draw it out. So let's say you have an aeroplane here. Okay, you have engine 1, engine 2, engine 3, engine 4. Okay, you need just minimum 1 engine in order to operate the aeroplane or just let the aeroplane fly. Right? So how many combinations minimally do you need to consider in this situation? Okay. Let's look at how you can apply MCDC in this example. Okay. The notes actually has the steps, but I'll just cover from a visual point of view. Okay. So first of all, this is called a truth table. In case some of you might not know. Okay. A truth table will actually show all the different possible combinations. Okay, given, let's say here we have 4 different engines. These are all the exhaustive test cases, okay, that you can test, okay, whether engine, whether different engines will work in this scenario. Okay, so in case you're wondering how many test cases are there, if you exhaust all the different combinations, the answer is to the power of 4. Why? Okay, let me just explain here. Okay, very simple explanation is you make it work or don't work. Okay, make it work or don't work. Okay, so one such example would be maybe you want all the engines to work. So this is the very first test case. Okay, E1 is true, E2 is true, E3 is true, E4 is true. So the airplane can still fly. Why? Because minimally there's 1 engine, okay, on each side of the wings. Okay, so the airplane can fly. Okay, so back to my question, how many combinations are there? So you can pick two scenarios on 1 engine. Okay, 2, 2, 2. So when you multiply them together, okay, 16 test cases. Okay, this is very important. So okay, so now when we look at this truth table, you can see that there are some cases that you don't need to think about. Why? Because if you look at the scenario, okay, minimally we just need 1 engine on each side, right? So suppose that the first engine is already running. Do we need to care about the second engine? Running, right? Because E1 and E2, like what I've drawn, is on the left hand side of the wing. Okay, if either one of the engines are operating, we can assume that the left engine is okay, left wing is okay, right? Similarly for E3 and E4, right? So actually, from 16 test cases, you can shrink it to actually about 9 test cases, right? So maybe I just backtrack a little bit. So for example here, between true and true, okay, some of you might have learned this thing called don't care value. Okay, there's no duster. So okay, don't care value means that you can treat the value as true or false. Okay, and it makes sense, right? So for example, you can combine this part and this part. So the green part and the orange part. Okay, because if you just look at it, the differences is just T and F. But what I mentioned just now is that if the first engine is already running, okay, you don't need to care about the second engine. So actually you can collapse these 8 test cases into 4 test cases. Okay, so if you look at the green parts, you can see that it's also the same idea. You can actually shrink the test cases. Okay, so on the left hand side, can someone give an answer? How many test cases can be shrunk into? Very easy. So you look at here, there's green part. Okay, you just focus on here and here. The difference between this part and this part is E2, right? So like what I mentioned, E1 and E2. E2 you can treat it as you don't need to care about E2. Right. So how many test cases would there be in the end? Just looking at the left hand side. You don't look at right hand side. Left hand side. How many would there be? Too challenging. Okay, maybe I just repeat one more time. Okay. So suppose now we have E1, right? Okay, suppose you have E1, okay, E1 that is running, right? So if E1 is already running, okay, we can be sure that the left wing, here's the left wing, here's the right wing. You can be sure that left wing is able to take off, right? So no matter what we have for E2, okay, you can treat it as a don't care value. Okay, don't care value means that okay, no matter is it working or not, the left wing is still alright. Okay, so likewise, let's say E3. Let's say E3, the engine is operating. Okay, actually you don't need to care about E4 because E4, no matter is it running or not, the right wing is still working. So yes, back to my question on the left hand side. How many test cases will there be remaining? 6. How you get 6?
This first and second row is one case.
Yes.
Third row, fourth row.
Then
5th row, 6th row is one case. Then 7th, 8th row. Those are rows.
So you mean this one?
This, yeah, those two are combined in one case.
Yes.
And then the top 2 are combined in one.
Okay. Okay. So yes, correct. Okay, the idea is that okay, so if you continue to work on this part and this part, okay, maybe because you all don't have pen and paper, okay, but the idea is that so if you continue working on it, in the end you see 3 test cases. Okay, so actually this one and this one, you can see that the output is actually the same. Okay, like what I mentioned. Maybe I talk about output. So for example, let's say if engine 1 is working, all the other engines are not working, so it's false. All right. So the airplane cannot take off. Maybe I didn't explain this part on the output. Another example. So suppose let me see one true value. Okay, suppose E2 is running, E4 is running, right? So one engine minimally each side, so it's a true value. So that means the airplane can take off. Okay, probably this one I can elaborate later when we end this workshop. So in the end, you become 3 test cases on the left hand side. Okay, just let you know. So there'll be 3. Okay, on the right hand side, if you combine like what you mentioned, okay, there will be about 6 test cases. Okay, so he's right. So there's 6 test cases on the right hand side. Okay, so like what I mentioned, so 6 test cases on the right hand side. Okay, here you see about 3 test cases. Okay, so if you have taken CS 100, okay, or CS 1231, that is on discrete mathematics, okay, you'll learn that you actually put a dash, okay, to indicate that it's a don't care value. Okay. Here we treat it as false. Okay. Later on, I'll explain why you should treat it as false. Okay. So right now we see that there are 9 cases. We assume that there are 9 cases. So we have decreased from 16 test cases to 9 test cases. Okay. So how this MCDC works? Okay. MCDC works in this way. Okay. So long as you tweak one of the truth value, okay, it should be reflected in another test case. Okay, so I'll show you what's the output. Okay, after you combine 9 test cases into 5. Okay, so in the end, it will become 5 test cases. Okay, I'm going to slow down and explain why. Okay, so right now you see that there are 9 test cases, right? Suppose that we take the first row. Okay, look at E1. Okay, E1 is a true value, right? Okay, MCDC works this way. Okay, if you tweak a value in E1, it means false, right? False, so false, false, true, false. Okay, the test case should return false. Okay, if it returns false, then you should include these 2 test cases over here as your resulting test case. It makes sense because you just want minimal test cases. I don't want too many test cases. Okay, so the idea here is that if I tweak one value, the other test case will catch it again and reflect it as false. Okay, so right now if you see E1, okay, if you change it from true to false, 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 true, false. Okay, so false, false, true, false must return false. Okay, if it returns false, then you can put in as your final test case, okay, for testing. Okay, so is this true? So if you look at FFTF, so FFTF is false. Okay, so the idea here is that if you tweak any one of the values, you'll be detected in another test case. Okay, if you don't believe me, you can try it over here. Okay, you can try to tweak any value. You can try to tweak any value here. You'll be caught in another test case over here, out of the 5. Not the 9, so not the 5. If you tweak any one of them, you'll be reflected in another test case. Okay, in the 5 test cases. Okay, so the idea here is you take one test case, you try one engine at one time. Okay, you tweak one by one, and you see whether there's a different output. If there's a different output, you put it in the final test case. Okay, so like what I mentioned, so since just now true and false, okay, just now I just tweaked E1, right? True and false. Okay, I'll put these 2 into this final test case. Okay, so now we look at E2. Okay, now we look at E2. Now we want to tweak E2 and try to get test cases which are different, which has different output. Okay, so let's say we take a look at this one. FFTF. Okay, just continue from here. So just now we only work until first 2, right? Okay, so suppose I want to tweak E2. Tweak this to true. Okay, if FTTF is true, I can put this inside the final test case. That's the idea. If it is false, you cannot put it. Okay, because it doesn't make sense, right? If you tweak any value, it doesn't get caught in the final test case.
So these 5 are like final states.
The final test cases that, okay, after filtering from 16 test cases, you can minimize it to 5 test cases. But the rationale is, okay, whenever you tweak any value here, you'll be caught in another test case over here, not the one on top. You'll be caught in another test case here, okay, and you can be sure that no matter how anyone tweaks the value, you'll be caught in the test case. Okay, so suppose somebody want to change your code, okay, to make sure that their site passes, okay, by tweaking one value. So if you tweak one value, okay, you can be very sure that, okay, you'll be caught in another test case in the red section, okay, and you will still be fine, right? Even though there's only 5 test cases, but these are 5 very good test cases. This is the idea, okay? So coming back to the example, so suppose I want to change this false to true, okay? since the output is false over here, I need to make sure that if I tweak the value, okay, the output must be true. If it's still false, I don't put in as the final test case. Okay, you can try any other examples, all right? So the idea here is I choose this particular test case as an example. Okay, if you tweak F to T, F T T F, you see over here, F T T F is actually true. So since false and true, they are different, you can put it in the final test case. Okay, and you can continue further, right? For this one, I think I took the example from, let me see, I can't remember this one. This one is, I think I took this one, right? Okay, so E1 and E2 is already settled. Okay, right? If I take one value, it will be settled. So let's say here I took this to false. TFFF, okay, TFFF is actually wrong. Okay, TFFF is false. Actually correct. TFFF is false. Okay, because right wing there's no engine operating, so false. Okay, so in this case you can add in the final test case. Okay, so I think I'll bore all of you if I continue. Okay, but the conclusion is this. Okay, if you have 4 different engines over here, there should be 4 plus 1 minimum test cases, okay, inside your final test case. Okay, this is the end. This is the moral of the story. Okay, so suppose you have you can change the engine to Boolean values. Okay, so for example, if you do engineering projects, maybe you have something like A or B and C. Okay, you can use this truth table as well, and you can come up with minimal test cases. It works the same idea. Okay, so you are wondering here, since we have 3 values here, the minimum number of test cases to cover is actually 4. So 3 plus 1. Okay, minimum 4 test cases. Minimum. Okay, if you use this approach, okay, rationale means that if you take any value, the other test case will get caught, right? You just need n plus 1 test cases. So is this okay so far? The slides will be uploaded. Okay, so this one I think this one is a bit extreme. Okay, I just want to push it to the extreme. Okay, this is actually the most difficult one. Okay, so that you guys can see how difficult testing can be. Okay, so at this point in time, any questions to ask?
I'm curious, but why is it that for the testing, right, you will purposely choose like if it's false, like the true and false, then the next one, right, must be the opposite true value. Why don't like, because if it's the same, then this thing doesn't work. For example, if it's false, like FFTF, if I change to FFFF, it's just 1, it's still false. Yeah, but it's not.
You don't include it.
Yeah, but why is it that must be the change the true value? Why can't it be the same?
Over here, we want a minimum number of test cases. Minimum. Okay. So it will make sense that let's say you tweak one value and the result is still false, you know, it implies that whenever if I tweak this value, this test case might not be caught in the final 5 test cases. Yeah, this one doesn't make sense. The idea here is the rationale of using this approach is just you tweak any value, yeah, minimize value, you tweak any value, okay, you'll be caught in another test case, minimally. Okay. So you can see that the power of this approach. From 16 test cases, you can minimize 1 test case. Yeah. Okay. But it really depends on the requirements that you are working on. If your requirements is not so strict, like for example, just tweak any value will do. Okay, you can use this approach. Yeah, that's why I would recommend using this approach if you can. Right? But the rationale is yes. You can only tweak 1 value. If you tweak 2 values, it might not work. Right? If you tweak 2 values, you might need to implement 4 test cases. Okay? Using the same approach, but you need a bit more test cases to come. Okay, any questions? Okay, no, right? So in terms of model, let's say you are doing decision tree models, you can use this approach. Okay, so let's say you want to test the different paths, okay, in your state diagrams, you can actually use this method. Okay, even the constraint just now. Okay, so so before I go on to this one, okay, here I'll mention 3 methods to generate test cases. Okay, I'm not sure if I can cover everything by today. Okay, but let us have 5 minutes break. Is it okay? Yeah, I think MCDC is a bit difficult, so I think you guys need to think through it. Okay, I'll cover probably the first 2. Okay, last one I'll see if I have time, right? So 5 minutes. Okay, after 5 minutes we'll continue. Is that okay? Yeah.
So you can 3 plus 1 equals to 4.
I can explain that. But this one is a bit on the screen. Okay, so the idea is you choose one test case, okay, then you have 4 different use.
You don't know about the equation, just the
ABC. Okay, so here, okay, I'll talk about this one. This one is easier. So here will be 4 plus 1 equals 5. Okay, this one is the reference. You take this as a reference. Then the rest of it, you just take the value. So that's why you have 4. In the end, it will be 10 plus 1. So use one test case as a reference. If you don't have one test case as a reference, you will have problems. So if you take one, then you might have another. So you need to keep one as a reference. So that's why you have 10 plus 1. So here and so you have 3 different variables. 3 plus 1 is minimum. You can implement more, but if you do not have time, or let's say you have some constraints, okay, minimally you implement more than 3. Which one?
Yeah, it's fine.
I hope it's correct because I didn't check this one. What is your question actually? Okay, you can come up with, you can use binary numbers. So you can start from 0, 0, 0, 0, 0. It might be easier to say because I prefer binary numbers. And I can see, let's say 1, 0, 1, 0, straight away I know it's true. It might work better for you. I think if you want to learn better, you can come up with this one. Then you will see it's actually in the notes inside. So this is called the modified condition decision coverage. All right. I think for the rest, it will be very straightforward. I can guarantee you it's very straightforward. Very straightforward. Just for this up, okay, if you want to know about category partition system, so the idea here is to use specification and try to find all the different categories to test. Okay, that's the idea about category partition. pairwise testing, you see a very interesting example later. And you'll see how pairwise testing minimize test cases. It will be very, very interesting. I think if you are inside, you can see the example that I posted. It is the same question. For one of the examples is of pairwise testing. Okay, so shall we continue? Shall we continue? Okay, so here are different methods to generate test cases. We are talking about black box testing, functional testing, which means you just test on the input and you see the output on its own. Okay, so how can you generate more inputs to test, more useful inputs? We are talking about useful inputs, not exhaustive, right? Exhaustive can be very easy, right? But sometimes exhaustive might be very difficult. For example, if you want to try all the different string permutations, it can be very challenging. Okay, it can be exponential. Okay, so that's why you need to find good quality test cases to test, right? So here I'll cover 3 of them. Hopefully I have time for the third one. So number 1 is on category partition testing. Okay, okay, so I won't bore you with the steps in detail. So I'll just go through one example. Okay, this example is very straightforward. So suppose you want to test this method, a factorial method. Okay, you don't know the implementation, so I purposely put in comments. Okay, so the restriction here is, let's say you have a negative n. Okay, it should return 0. Or let's say if it's out of range, let's say the value of n is out of range. Okay, it should return -1. Okay, otherwise it should work like how a factorial method works. Okay, so okay, I'm going to introduce this concept, very simple concept. This is called independently testable features. Okay, this is not in the notes. Okay, but this one is very important. Okay, you need to identify independently testable feature. Okay, what is this independently testable features? Okay, it means that suppose you have this particular method to test. What is the first thing that you should look at? Okay, when you before you look at the different categories. Okay, so for this one, I'll just give you the answer, and you'll see why. You will see how this independently testable features work. Okay, so this factorial method, there's only one implementation, just to compute the factorial of a number. Okay, so this is one independently testable feature. Okay, suppose you have a method, you are doing multiple things at once, so there could be more than one independently testable feature. So it is like a category in that particular method. Okay, and a very general category. You can think of it this way. Okay, usually this testable feature, when you put in the input, you can get the output. Okay, if you put in the output, if you put in the input and not get any output at all, this is not called a independently testable feature. Okay, so so for this feature, it's very straightforward. Okay, I have the input n. I want to calculate the factorial of n. Okay, I want to return the factorial of n. Okay, if I could not return due to the constraints above, then I need to return a error code in this case, either 0 or -1. Yes.
So how is this any different from, let's say, unit testing? You are testing an independent feature.
So this is in terms of code. In terms of code, okay, sorry, this is in terms of code. Okay, just now like model testing is based on the whole system on its own. Right? For the whole system, when you talk about let's say a traffic light, you look at the different lights, right? You look at the methods inside the traffic light. Okay, so here functional testing, we look at in terms of code, okay, but not inside the code itself. Okay, but we look at the method itself, what the method is doing as in general. Okay, we don't really look at how the factorial method works, but in general, what is this method doing? Okay, so over here there's an input, the input is n. Okay, I just want to calculate the output is the factorial of n. So there's an input, there's output. Okay, input is n, the output is factorial of n. So testable feature must have these two parts, input and output. Okay. So after you identify what are the testable features, okay, you identify the parameters and the environment. Okay, so very simple. Parameters means, let's say, here, there's only one parameter n, that's it. Okay, some methods can have more than one parameters, so you just identify the parameters, that's it. Okay, environment means that what kind of system are you running on? Okay, I think if you are doing programming, you should be very familiar. Okay, if you implement this using C or using Java, okay, the constraints will be different. So when you implement using a 32-bit computer or a 64-bit computer, the computation will be different. The range of values that can accept for int can be different. Okay, so whenever you do testing, you should take note of the environment and the parameters as well. Okay, so this is very I'm showing you in a very systematic way, okay, on how you can do the testing. So after you have found the parameters, the environment, okay, and the testable feature, you come up with the categories. Okay, notice that until now I still don't see the implementation of factorial. Okay, from what I know over here, I only know that okay, there could be a negative value of n. There could be a value of n which is in range, right? So from so according to 32-bit or 64-bit computer, the range of ints over here, and it could be out of range. Okay? Because like for example, 20 factorial, it could be a very large number. Alright. So when we see such a large number, it should return -1. Right? So these are the different categories that you can look into. Okay. Some of you might be asking, how come you don't consider strings and all that? Okay, that one will be covering in another method. That is called a catalog testing. Okay, so as of now, we just focus on assuming n is a number, okay, and what are the possible inputs for n. Okay, not looking into the code, just looking at the surface level. Okay, so after you have found all this, okay, you can come up with representative values. Okay, usually representative values are boundary values. Okay, so suppose that these are the parameters that we have found. Okay, so just now we mentioned that negative numbers, numbers which are in range, and numbers which are out of range. Right, these are the parameters. Okay, so suppose that okay, here we have 0, here we have maximum. Okay, usually when we do this category condition testing, okay, usually we test at the boundary. Okay, usually we test as close as possible to this boundary value. Here, factorial the boundary value is between 0 and the maximum. Maximum here means depending on the environment you're working on. Okay, suppose 32-bit, the maximum could be 12. So for example, 12 factorial, I think that is the largest number that you can pick for that particular method. Okay, 64-bit, maybe 20 factorial, that's the number. Okay, so the idea here is to test, to set values which are as close as possible to the boundary value. The boundary value here will refer to the correct inputs. Okay, so all those inputs which are not valid, or let's say they are negative, okay, we try usually one number off from the boundary value. Okay, so okay, enough of explanation here. So here we can see the different representative values you can come up with. Okay, so you can test n less than -1, n equals -1, 0, 1, okay, inside the range, max -1, max, and any number more than max plus 1. Does it make sense? Does it make sense for all of you in terms of this part? So the idea here is about the boundary. You need to find where are the boundaries to test. Okay. Ideally, you should test every single section over here. Okay. So that is the idea. So that is how I come up with the values over here. Any questions? Is it straightforward? Straightforward, right? Okay. So sometimes depending on your program, depending on your code, okay, there might be some constraints. So for example, like maybe your method, you need to call some other methods in order to make it work. Or maybe for example, your code itself, maybe you don't accept numbers which are multiples of 3. That could be one example. So you need to consider those constraints as well. Okay. So when you come up with, after you come up with the representative values, okay, usually they are boundary values. Okay, then you think about the constraints and see how you can minimize the number of constraints, minimum number of representative values. Okay, so just now you have seen that there's about more than 8 representative values. Okay, here we want to see the constraints and see if we can shrink it to as minimal as possible. Okay, the idea here is to make it as minimal test cases as possible, right? We don't want to test so many test cases, right? Otherwise, your program will be very slow. You will waste a lot of time in testing, and that's not what we want. So, okay, so after we have found that, okay, there are no constraints to consider, okay, we will try to come up with values which represents all these representative values. Okay, so it's rather straightforward now. Okay, just that we need to take note on the environment. Here, the environment comes into play. Why? Because the max can take 2 values, depending on which computer you are running. Okay, 32-bit will be computers like 10 years ago, right? 64-bit is the computer you are running right now. Okay, depending on your requirements. Okay, sometimes your project, okay, sometimes your professor will be running on a 32-bit computer. Okay, you cannot get your A plus. So, okay, it's very, very important that you think of the environment as well. And sometimes this could be a main reason why you cannot get an A plus. Okay, so so for these 2 environments, okay, we are only concerned with the last 5 points over here, last 5 representative values. So we just need another 5 more, okay, for these 2 environments. Okay, so here is one example on all the different test cases based on the boundaries that we have set, based on the parameters, based on the environment. Okay, and you can implement this with just maybe 12 or even more. So this is probably a few more. Maybe I didn't put in some more. So it should be close to about 20 test cases. Okay, if you want to if you see other people implementing, you might see them implementing more than 30 test cases, or even more, or even 100. Okay, so you don't need to test so many, and this is the idea. You find the different categories, okay, you partition them properly, and you come up with test cases based on the boundaries. That is the conclusion of this testing paper. Okay. I think the next one is pairwise testing. Okay, so at this point in time, any questions? I hope this is straightforward enough. It's not as complicated as just now. So if you look at the notes, you'll be very, very systematic. So you look at the different areas and come up with the representative values, boundaries, and come up with test cases based on that. Yeah, if you follow the steps one by one, yeah, you can come up with the test cases systematically and not randomly. Okay. Any questions before I move on? Any questions? Any questions? Okay, if not, okay, I'll move on to pairwise testing. This one, I think we can try on paper. All right, so this is a rather interesting problem. So suppose you are a restaurant owner, okay? You want to create different side dishes, okay, for a customer in the restaurant. So you have the main dish, side dish, and drinks. Okay. Constraint here is there's only one dish from each category. So the meal itself, let's say the plate, you can only select one from each category. Okay. And due to some internal policy, the corn has to be together with the burger. So question here is, I want to generate the minimum number of test cases possible. Okay, so I give all of you 5 minutes, try to come up with as many test cases as possible, but minimally. Okay, minimum. Okay, so 5 minutes to try out this problem.
What do you mean by minimal?
Yeah, minimum. So if you want to implement exhaustively, so you can choose each of the side features. So that can be quite a lot of test cases, right? So the idea here is not to generate so many test cases. So try to see how many test cases can you find. So just the important test cases.
So what criteria are we looking for?
Here, over here. So one dish from each category, right? And the corn must be together with the burger. Yeah, that's it. Yeah, have a try on this problem, and we will go through one of the other method to test. Okay, for testing. This method is called pairwise testing.
6.
How can it be 6?
3 more.
I don't know. How it's 6? Random. I don't think it's 6. Because you're milk here, right?
I just need to test milk and choose one time. I don't have to test it for every other person.
Okay. So later on when you see pairwise testing, you address this constraint, this concept. So have you considered the other pairs? Which one is one? That is the question. So you consider like milk and something else like milk and juice, right? Just as one. But have you considered the other things? For example,
That's why there are 3 as that. There's only 2. I can test 1. Sheet 7.
then how about burger, fries, on that?
No, I think.
Okay. You guys can try to write out the combinations. Later we will match.
Four.
Okay, before.
I don't understand. You're trying to test all the
So all the possible
dishes,
meals.
right? But you only want one dish.
So I need to select one.
Burger,
dish.
corn cola, burger, corn juice, burger, corn milk. And then test all the drinks already. And then after the fry salad and one other.
Something like that. What's this?
That's 4.
But there should be more. Cannot be more. Here we have 7
Burger and salad, fries and
But you are just testing all the dishes, right? You only test each dish once, right?
you want to test the combination.
combination.
Oh.
So I can choose like for example fries, salad, and milk. That's one. The thing is you cannot choose more than once. But you must have one combination. How many do you come up with? How many do you come up with? Three plus three. Later you know why. Not in so much. Okay, how about you guys? Okay. How about you guys? It's okay. You can see that this is not a programming problem. It can be used. This is not it's not really programming problem. But you can come up with this as a code implementation. Suppose you need to design a software that generates all the different combinations. Okay? This is also possible. But this one I try to make it less programming intensive, okay, so that it looks more pleasing to all. Okay, so maybe I shall go through the answer. Okay, but meantime, please take a look at how this pairwise testing works. Okay, this is a very interesting concept. Okay, in the end, you should have seven combinations. Okay, you should have 7 combinations. Okay, if you see how I do it, okay, you understand why. Okay, so for this pairwise testing method, it's very easy. Okay, very first step is you sort the columns. You sort the columns. Okay, so the most number of items in that category, you put it to the left. Okay, then followed by those which are lesser. Okay, so over here I move the drinks from the 3rd column to the 1st column. Okay, so Yeah, so this is the difference between the two, right? The rest is the same. Okay, so take note of this table later. And what we are going to do here is we will generate the combinations for I'm sorry, I didn't change the table. So for drinks and for main. So this table. So I want to generate the combinations from here and here. So how many are there? 6, right? 6. Do you see why? So three combinations and 2. So 3 times 2 is 6. Okay. So and how do I come up with the 6? You should take a look at how I write the 6 combinations. Okay. I write the main dishes in this way. Okay. In a pattern like this. Okay. So I write cola, and then I look at because the drinks I didn't move it. So you look at burger and fries. Okay, since there are two dishes over there, so you write it 2 times. So over here you see I write it 2 times, and then different main dish I write 2 times, and this one I write it 2 times. Okay, this is very important. Okay, this is not elaborated in the notes. So this is how you write the very first step for the table. Okay. After that, you consider the side dishes, right? You consider the side dishes. So looking at this one, okay, you can take the main as well. Okay, they are the same value as well, same number of side dishes, same number of dishes, right? So look at drinks, look at sides. Okay, I want to consider all the different pairs. Okay, I want to consider all the different pairs for drinks and sides. Okay, so if you follow me, cola, the first one you should put corn, right? Okay, first one you should put corn. Second one, should we put corn again? No, right? You should put salad. Does it make sense? The second one. So here, let's say cola. Here you put corn, right? Second one, should we put corn or salad? Salad, right? Makes sense, right? Okay. Then you have finished this particular combination for corn. Okay. Corn and salad for cola, right? So if you continue for juice, okay, you do it repeatedly, and you should see something like this. And I don't know what happened. Okay, my main dish came first. So okay, same idea though. Okay, if you use sides or if you use main, same idea. So the idea here is if you choose burger, okay, then the next one you cannot choose burger again. It doesn't make sense, right? So cola and burger doesn't make sense. So you choose fries. Okay, so you can do this and then you check. Now you need to check the pairing, whether you are satisfied with all the different pairings for drinks and main. Okay, so just fast forward this part. Okay, drinks and main, no problem. You have to consider all the different pairings, all right, for drinks and main, definitely. Okay, so over here you can see. Okay, so now the hard part is the sides. Okay, how should you fill in the sides? Okay, do you just fill in repeatedly like this, like corn, salad, corn, salad, corn, salad, something like this? You put something like this. Do you see any issues? Do you see any issues here with this table? Here the issues is here. So if you see the combinations, you check all the pairings, drinks and main, drinks and sides, main and sides, you see that there's this missing combination for burger and salad straight away. Can you see? If you cannot see, you can raise your hand. I can show you how it works. If not, I can fast forward. Can all of you see this? Burger and salad is missing, right? Okay. How about salad and corn? I don't know why I put question mark there. So how about salad and corn? Can someone tell me? Is there an issue? Any issues with salad and corn? So here, I suggested something. So since we don't have burger and salad, right? So Because you can see all burger, corn, burger, corn, burger, and corn. Maybe your suggestion is, oh, let's switch these two. Let's switch these two. Do you think it will work? Do you think it will work if I just switch this way? Okay, I can tell you it does not work because we want corn with burger. If it's burger, we want it to be corn. It cannot be salad. So you cannot just swap like this. Okay? Likewise here, you cannot just swap like this. Right? Make sense? Because the constraint is there. If you want burger, the corn must be there. Okay? So how? Like this, what can I do? I cannot swap anything. See, I do all the swapping already and it doesn't make sense. Then how? Okay? So for this burger and salad, you need to add one more test case. And that's why it's not 6 test cases, but 7 test cases. Just because of burger and salad, you can't really tweak the values such that all the 6 test cases will work. And you check all the pairings, all the 6 pairings, all the different pairings will make sense. Okay? So okay, you add burger and salad, right? Burger and salad. Because it makes sense, right? I never say burger cannot go in salad, right? So here, the drinks. What should be the drinks over here? If someone can tell me, you'll get something good.
Don't care, right?
Why don't care?
Doesn't matter.
Doesn't matter, right? So I just want that particular pairing there, burger and salad. I just want the pairing there. Okay. So if I put cola, if I put milk or juice, it doesn't matter. So the idea here is, yeah, you don't need to care about what is the value. Okay, so answer is you can put any value. Okay, if you are interested, this is actually a midterm question. It looks simple, but yeah, this is the midterm question.
So why is it don't care?
You can put any value and it makes sense. Basically, why we put this test case is because we are missing with this combination. This pair. This pair is missing. You look at the top. This pair is missing. You cannot take the value like what I mentioned just now. Because the
So even though there are 3 categories, you're only looking at pairs, right? Main, drinks, main sides, and sides.
That's why it's called pairwise testing. Yeah. Okay, does this make sense? So the idea here is you consider all different pairs, okay, and from there you let's say if there's a missing pair and you cannot check any of the value, then you need to insert a test case for it. So this is how you can minimize your test case. You don't consider 2 to the power of 7 in this case. You don't need to consider 2 to the power of 7 test cases here. Here you can do it in just 7 test cases. Okay, any questions for this? I hope everything is correct. If it's wrong, you must tell me. If it's burger, then you should eat corn. I type wrongly. Say burger salad. Yeah. If it's burger, then must be corn. So I think it's a typo. I think it should be fries and corn. It should be fries and corn. Yes, that's not also funny very good. It should be fries and corn. Yes, fries and corn for the last one. Because burger must go with corn. Right? So the last one should be fries and salad. So, fries salad. I'll change the slides later. So don't worry.
Fries and salad.
Fries and corn. Fries and corn. Fries and corn. Okay, cool. Hopefully you see the beauty of this test case. Method.
Why is it not burger and salad?
Yeah, burger must go with corn. So that's a typo error. Yeah, that's how I find it very good. Okay, cool. Okay, for the last 10 minutes, okay, for last 10 minutes, I'll cover the last method. Okay, this last method is very easy. Okay, last method is very, very easy. Okay, it's similar to the category partitioning. Okay, it's just that you don't consider the requirements. Okay, that's why we look at factorial, right? We look at the requirements. For example, negative value of n. For example, integer out of bounds, right? So for catalog-based testing, okay, we are looking at the inputs, okay, the preconditions, the post-conditions, and how the methods is defined. Okay, so for example, let's look at this method. Okay, so let's say if we have this is valid tag method. Okay, so can someone tell me what are the independently testable features? This one is very straightforward. So suppose you put in a string, okay? The criteria is first three characters are letters, followed by 1 to 2 digits. So what is the testable feature here? Anyone can tell me? Anyone? If not, I'll move on. It's okay. So for this testable feature, okay, like what I mentioned just now, it follows this standard format. Okay, it must have the input and it must have the output. Okay, so here it's very straightforward. For this method, we check that the sequence of characters for the string is a valid tag. Okay, so the output is a valid tag number, a tag string over here. Okay, so the input is a sequence of characters for string, the output is a valid tag. Okay. So for this catalog-based testing, it's very interesting. You just look at the preconditions and post-conditions. You just brainstorm like as though you are not implementing the code. Okay? As though you are just looking at this and you think about the precondition, the post-condition, and you come up with test cases based on the conditions. Okay, this is just an example. So you can come up with more than 2 or 5 examples over here. Okay, I believe there are many more. It's just that the idea here is for each condition, you come up with a test case for it. Okay. So so if you look at the notes, I'll talk about the definitions, the variables, and the operations. Okay. Operations, I just elaborate a little bit. So in case let's say your method has some implementation, let's say you change the string to something else, or let's say it does some form of manipulation, then you can indicate the operations part. Okay. Definitions is basically how the string is like. Okay. So it's just first three characters are letters, and followed by 2 digits, 1 to 2 digits. So so the next step, okay, after finding all the precondition, post-condition, definitions, okay, and operations and all that, okay, you come up with a test, you come up with a scenario which is directly the opposite. Okay, so suppose your precondition is the one in blue, okay, you come up with those which are in red. Okay, you want to cover the other side as well. So you don't just implement the correct input as well. Okay, you need to implement the invalid input as well. So that's why you implement the invalid parts in red. Okay, I hope you get the idea. So it's very straightforward. So you just do, if you know De Morgan's law, so you just do a De Morgan's law to it. Right? So if you want between 4 to 5, then you want less than 4 or more than 5. That's the idea. Okay. So the idea here is to list down the possible combinations. Okay. Preconditions. I believe I covered most of them, so that's why there's no indication in red. But there could be more, right? There could be more. So for this catalog-based testing, the idea here is you look at this table. This is a sample catalog, and you go through one by one. Let's say if you are looking at a string variable, then you look at, let's say, a sequence, right? You look at sequence, right? Then you look at each and every one of them, and you see whether it applies in your project or not, or in your method. Okay, if it applies your method, then you come up with a test case for it. This in out means your input output. Okay, depending on which is the variable that you are interested in. Okay, so for example, if you are interested in Boolean value, there's only two types of Boolean value, true or false. So let's say you want to come up with test cases with regards to Boolean value. Just look at this catalog. Okay, Boolean means okay, I need to implement two test cases. That's it. Alright. So let's say you want to implement test cases for constant. Let's say for a factorial, your n. Right? You can look at all this. Is exactly what I mentioned just now, the boundary values. Right? The exact value of c minus 1, c plus 1, and any other constant in that data type. So any other constant meaning the range values, let's say for integer, let's say for long, let's say for float. Okay, so this one actually I covered it just now a little bit. So these are the different catalogs you can take a look. Okay, and the idea here for this type of testing is that you look at the catalog and you do systematic test cases systematically. That's the idea. It's just straightforward. Just look at this table. Divine constant. Okay, these are the 5 things I need to implement. That's it. But you must really filter whether it really applies to your method. Okay, so that is the limitation. Okay, and actually that's it for this type of testing. So just a recap. So there are 3 different methods that I discussed. One is category partitioning. So category partitioning, we look at specification. Right? We look at the specification. If you look at, let's say, the factorial method, I only look at the specification. Like, what is the constraint? What are the requirements? So factorial means I just need to calculate the factorial of n. That's it. Okay? I don't look at the precondition, postcondition. I don't look at the individual data type. Okay? Over here, I look at the data type. If you notice. So catalog-based testing, I look at the data type. I look at the precondition, postcondition. I look at the definition as well, okay, and try to see for each data type, the different combinations which are possible. So usually catalog-based testing is usually done during acceptance testing. So when you see the product working, okay, and you want to test whether the product is working or not, okay, you can come up with different scenarios. For example, your authentication. Let's say your email address and password. You want to test people's code, email address and password. You can look at these and straight away you can come up with test cases for it. That is the powerful thing about catalog-based testing. Okay? And this is the difference between catalog-based and category partitioning. Right? You don't look at the use case, you don't look at the user stories, you don't look at requirements. Okay? Any questions to clarify or anything to add? Okay, so I hope this is good enough. I didn't have more things to cover. So I want to do structural testing, but I don't think I have time. Okay, I'll just show you how it works for structural testing. Okay. So this is just to show you, okay? This is just to show you how you can represent your program, okay, using a control flow graph. Okay. Remember you draw the state machine, the state finite machine diagram. It is very similar. So that one you can implement using from a hardware perspective. For example, your traffic light, your vending machine. Okay. So in terms of code, in terms of software, okay, there's a similar thing which is called control flow graph. Okay. So if you want to show the different flow, okay, between each line of code, you can represent it in this way. Okay. So this is like for while loop. Okay, you go into this loop. Okay, if else you will branch out. So if yes, you go here, no, you go here. Any questions for this one? Is it straightforward? Okay, this is just for awareness, right? Just for awareness. Okay, so that's how we look at from line by line, right? We look at line by line point of view. So what about if it's across methods or across different classes? Okay, it can be done as well. Okay, so it's not just for line by line code. It can be applied for different methods. When you call different methods, it can be used as well. Okay, this is just a very simple example. This is just for awareness. Okay, and this one I will not talk about it. Okay, I think all of you get it. So the agents is like going from one code to another. Okay, I intend to ask you all to do this, but I don't have time. So I'll skip all this. The idea here is I want to emphasize on this one. Okay, so if you draw the state machine or if you draw the control flow graph, you can identify the cases that you have never seen from the specifications. Okay, and then you can determine the coverage, okay, manually. Okay, this is actually my last slide. Okay, this is how you can determine the coverage criteria. Okay, it looks overwhelming, but actually, if you look at the formula, it's very straightforward. Okay, statement testing, you just count the number of statements that you have executed over the total number. If you look at next one, branch, total number of branches over total number of executed branches over total number of branches. Yeah. So you look at executed branches over total number. That's it. Okay, condition is also the same. Condition is like, okay, if you understand this formula, this is like considering all the possible conditions using the truth table. So that's why it's the 2 times number of basic conditions. Okay, so number of true values, like for example, how many true values are true in this case. So this is the condition testing. Alright, path testing is basically you look at your state machine diagram and you look at your control flow graph. You consider the different paths which are possible. Okay, you count the number of paths which have went through over the total number of paths which are possible. Okay, so actually this is about it for structural testing. So if you want to maximize your coverage for your structural testing, you can use this as a gauge and see whether you can hit 100% or not. Sometimes it's not possible to hit 100%. Okay, because sometimes your code might be implemented in a way that you need to throw exception for certain cases, and it's not possible to catch when you do testing. Maybe that's one example of not possible to hit 100%. Okay, so this is how you can use this and gauge whether you can increase the coverage or not. Okay, so this one I already mentioned just now. So the idea here is you write a small part of code and then you write a test case for it. Okay, you try to run that test case until you pass and then continue doing it. So it is the idea that I mentioned earlier in the workshop just now. So you do it repeatedly, just a small portion of the code. You do it incrementally. Then you will realize that you have a lot of test cases, and then your code will most likely not fail actually. Okay, but you don't rely too much on this. You need to do other forms of testing. Okay. Okay. So due to a lack of time, okay, I can only mention these 5 things that you can do to enhance your testing process. So number 1 is automated testing. Okay, there are a lot of tools online. For example, JUnit that you can use if you are using Java. Okay, build automation. For example, if you use Maven or Gradle in your project, so you can import all the relevant necessary dependencies in your project. Okay, continuous integration is if you have went for the workshop during liftoff. Okay, there's a part of continuous integration. You can take a look at it. So this is the idea where you can run test cases automatically once you have made a copy. Okay, for example, you can use Travis CI, you can use Jenkins. So these are some tools that we use for continuous integration. Alright, so if for IDE, you can use breakpoints to check each line of the code. I wanted to show this, but I didn't have time, and as well as coverage report as well. Okay, coverage report it can be done in the IDE itself. Okay, so yeah, I do not have time to show this too. So I'm very sorry for this. Okay, I do not have anything else from here. So any questions, final questions to ask? If not, you can ask me later. All right. I think we should go for lunch right now. And thank you for your time. Thank you.